Hello everyone, welcome to this video. In this video, I am going to talk about a very famous book in the ML domain. It is called Designing Machine Learning Systems. It is written by Chip Yuan. So before beginning on the actual book review, I wanted to highlight a very important aspect. What I have seen in the data science industry, it is how data science is being taught. So generally, instructors tend to follow a path where they teach about Python, then they focus on various machine learning algorithms, and then we have stats and maths behind it. So that's generally what people do, and the projects are generally centered around Jupyter notebooks in which people tend to clean their data, and after that they train their models and maybe um, get artifact of that of your model, and then you try to infer it. So this is what 90% of people are teaching, and as a beginner, that is fine. There is no problem in doing that, but there are certain aspects of it which aren't taught, which are related to ops. So what this book is all about, it teaches us how machine learning meets production, right? So how things go down in production, it teaches us that. So who this book is for: if you are someone who has basic understanding of how machine learning works, how the algorithms work under the hood, and you have made certain projects, even if they are simpler ones, it's fine, but you have some hands-on experience. So this book can help you a lot. Why? Because this will teach you how the use case that you have solved with the help of machine learning can actually be applied to production, and your models can actually be served to the users. So this book talks about that. So one prerequisite is have some basic understanding of how machine learning works. So guys, let's begin the actual book review. So the first most important thing that the book talks about is the concept of production. In production, we have a different scenario as compared to research or any other environment, because generally we have three stages in the development process. It is the dev stage, the test stage, and then you also have the production stage. So we are generally in the dev stage, where we are building the model and experimenting it with different hyperparameters to get the best output. And in the testing stage, we actually test the model, and then you have the prod stage in which your model is deployed for the users so that they can use it. So this is how generally the cycle goes on, and there are different people involved, or sometimes if the company wants, they can have just a solo full stack data science guy in their company who is handling everything, but that generally is not preferred. That's why we have three stages, right? So this was the first point which the book talks about. So when we are introduced to working in teams, the one of the major issue that everyone faces is coordination among team members. So if I want to know what my team member did, I would have to go and personally ask him, but that is not the standard. We use tools like Git for versioning, and then we can of course see what our team members are doing, on which code part they are working, right? Which part of the process they are at currently, and everything else that you want to coordinate, you can see in Git. Apart from that, we have tools like DVC. Even though I haven't seen people use it in production, but it is a very good tool. Especially when you are making your portfolio projects, you can use that, and it can highlight that you are actually concerned about your data and how it is being used at different stages. DVC is just a tool that is used for data versioning. Like Git is used for code versioning, DVC is used for data versioning. One other challenge that companies face is how will you track these changes. Like you have a model, it was trained using a certain hyperparameters, it was trained using a certain model, let's say linear regression. Then it would have a certain level of accuracy, right? Let's say R2 score, for example, if it is a regression task. So how will we track these changes across different models? So for that, we have a tool called MLflow, and it is a very beautiful tool. I think everyone should be aware of how it is used. One other issue that the book talks about is how models are deployed at scale. So when we are training our model in, let's say, a Jupyter notebook, we have trained it. and we are using certain independent features that we are feeding to our, let's say, pickle file to infer it, right? We will get certain value. Let's say if it is regression, we'll get a continuous, and if classification, then we'll get a category. So that is how it works generally, right? This is how we generally do. But if this model is to be accessed by thousands of people at the same time, then we want this model to be deployed somewhere, let's say in cloud. And in cloud, if this model is deployed, we can access it parallelly by multiple users, right? It can be accessed by multiple users. So we generally don't tend to explore areas which are related to cloud when we are studying data science, but when the model is deployed at scale, these are the issues that and challenges that we have to face that the book talks about. Apart from that, we also have certain issues which are related to data distribution shifts. So for example, there is an independent feature which ranges from 1 to 10, right? And your model during training has seen these range of values only, right? Between 1 to 10. But when the model is deployed and people are actually using it, if the data distribution shifts and people start to give input to the model, let's say 1000 or 500, 400, something unusual which the model hasn't seen, and it goes on for a long time, then the model starts to degrade and its performance will not be that good as compared to when it was earlier, when it was trained, because this distribution has changed. So this generally happens, and then how do we counter it? We generally retrain our model. So the book also talks about what is the ideal frequency in which this retraining is supposed to happen. So every company has their own norms. There is no such ideal case. Like, we can monitor data distribution shifts, and then if we have encountered that yes, indeed our data distribution has been shifted, then we can retain our model. Apart from this, there are other problems, and there is one more problem. How will you actually notice these changes in the data distribution shifts, right? So for that, we have tools like Evidently. This is a tool which can be used, and I have also written a blog about it, and I'll drop a link to it in my description that you can go and check it out. There is another important aspect that the book talks about. It is called testing in production. So yeah, that might seem really crazy that we are going to test our model in production, but that is actually the industry norm. What happens when we deploy the model at scale without testing, or let's say without testing it in production environment, is that if we don't get good results, we are stuck with the model, and then it will take time to get the model down and replace it with another model which is doing good. So we generally tend to do deployment of the model alongside our main model. So we will have two models in parallel. This one will be the earlier model which was already in production, and this will be the new challenger model, and then we see which model is working better. In certain scenarios this might work better, and in certain scenarios this might work better. We have techniques like A/B testing, shadow deployments, canary release, which the book talks about. In A/B testing, we try to deploy our model parallelly, and then different set of users are shown different models, and then you get the feedback based on the model's accuracy and whatever metric that we are tracing. The book also talks about a really important concept, which is build versus buy. So when companies are deploying their models, they will need servers that they can be on cloud. Like, we can use any managed service, which is AWS, Microsoft Azure, or GCP, or any other cloud provider of our choice. Or it can buy physical servers that it can host in premise, and can have a engineering team handling those piece of hardware, right? Generally, companies prefer managed services when they know that their data is not that sensitive, right? And if they know they are dealing with highly sensitive data, they cannot let this data go outside their building premises or company. So they just buy the physical servers, right? this is how they solve that problem. Lastly, I want to emphasize on a point. After reading this book, you should try to build something, right? This book just teaches you about different aspects of how things go down in production, but if you haven't applied what you have learned, it is of no use. So I also made a project. It is called E2E ML pipeline. I will drop the GitHub link to it after reading this book, right? So you can check it out. And yeah, that's pretty much it. So to summarize, all in all, this book is for someone who is not new to machine learning, has some basic understanding of the ML domain, and wants to see how things go down in production, and wants to up their game of moving from Jupyter notebooks to code and then creating their own pipeline, right? And then seeing everything work in a ordered manner. So yeah, thank you so much.